Good morning, students. Today we will start discussion about two-dimensional coordinate geometry. And the first point towards discussing that two-dimensional coordinate geometry is the coordinate system. Before I proceed further, can you please confirm, someone of you, that you are able to hear me very clearly, able to view the screen properly?
Yes, sir.
Okay. So in two-dimensional coordinate system, okay, uh, it is required to represent a geometrical point by means of algebraic method. Okay, and that is true for three-dimensional coordinate geometry also. But in two-dimensional coordinate geometry, a point is specified as ordered number pair and is known as the coordinates geometry. So what is mean by that? It mean by that is that suppose you have a point, and this point in the plane of this whiteboard. Suppose this point is there in the plane of the whiteboard, and how we can represent this point? We need to represent this point as an ordered pair. Okay, as an ordered pair, and these are the and is known as the coordinate system, the ordered pair. Now, in general, there are two coordinate systems, we know. One is called the Cartesian coordinate system, and another one is called the polar coordinate system. Okay. So if I keep the note in front of you, so it looks like this. Okay. So it says that in the system of geometry, it is required to represent geometrical points by means of algebraic methods. In two-dimensional geometry, a point is specified as ordered number pair and is known as coordinate geometry. In general, there are two coordinate systems as mentioned below. One is called the Cartesian coordinate systems, and the another one is called the polar coordinate system. Now, before I proceed further, you may have a question that, sir, why it is a ordered number pair? You may have a question why it is the ordered number pair. Okay, so the reason is very basic. If it is less than that, you cannot represent a point uniquely. Okay, think about, you already aware of Cartesian coordinate system to some extent from your previous year's classes. Is that instead of two axes, x-axis and y-axis, and if I give you a point, instead of assume that you do not have any y-axis, you only have x-axis. Okay, you only have x-axis, and how you represent a point? Suppose this is origin and this is x-axis. Suppose I say this is a point. How you can represent? You can only say that how far it is from the x-axis, this distance, right? Means especially I can say how far it is from the x-axis. But that information is not sufficient to represent that particular point uniquely. Why? Because there are many other points, this point, this point, this point, they are all same distance from the x-axis. So how we can represent it uniquely? And that's why there is another system, another reference frame we know, that is actually we bring y-axis. So that now we can say this particular point is whatever the distance it is from the x-axis, it also has a distance from the y-axis. Now both these combinations are unique. Suppose if we call this point as P, you cannot find any other point P, any other point which is having the same distance from the x-axis and y-axis. Suppose this point P is at a distance beta from the x-axis and alpha from the y-axis. Then why you can say its coordinate is alpha comma beta. Now what I wanted to mean is that it is impossible to find any other point which is at a distance alpha from the y-axis and beta from the x-axis. Impossible. So now as it is impossible, that means the ordered pair representation of the point P is unique. So that is why it needs an ordered pair. And dear students, when we will discuss about the three-dimensional geometry, okay, after a few months, then we will see to represent this point in three dimension, we need, three, information. Okay, it is no, it ordered pair will not be sufficient. You need to add one more. Okay, it should be, a triplet. So now let's come back to our discussion. In general, there are two coordinate systems, we know. The first coordinate system is, which is very popular, is known as Cartesian coordinate systems. And the next one is called the polar coordinate system. Now, dear students, that you may be thinking that why there are two coordinate systems. Okay. It is, it is the, the way we can represent that ordered pair uniquely. Okay, for example, when we measure distance, there are different units you find, right? You can measure the distance in the unit of kilometer. You can measure the distance in the in mile. Okay, so both represent the distance, and there is a relationship between miles and kilometers. Correct, dear students? Similarly, you are representing a point, but you are representing a point in one system called Cartesian coordinate system and another called the polar coordinate system, but both represent the same point. Okay, and also, as I said, by means of an example analogy, is that there are relationship between the kilometer and mile. Similarly, there are relationship between the Cartesian coordinate system and polar coordinate system. Both are described in ordered pair, but there is a relationship between these ordered pair. Generally, when I say the ordered pair in Cartesian coordinate system, the ordered pair is something like this x comma y. And in polar coordinate system, the ordered pair is r comma theta. And both represent the point. And we will find the relationship between x, y, and r theta also as time goes by. But before that, I would like to discuss about the Cartesian coordinate system. What is Cartesian coordinate system and what are the different attributes of a Cartesian coordinate systems, that we'll discuss now. So, to discuss about the Cartesian coordinate system, let me take you to the next page. So as you see, dear students, in the Cartesian coordinate system, let OX and OY be two fixed straight lines perpendicular to each other in the plane of this, whiteboard, what you see. The line OX is called x-axis and the line OY is called the y-axis. And the two lines together called the axis of coordinates. Now let's take P be any point in the plane of this whiteboard, what you see. And now let the point M and N be the foot of the perpendicular from the point P on the x-axis and y-axis respectively. And let us assume that OM, which is equal to NP, is equal to alpha, and PM, which is equal to NO, is equal to beta. Correct? So these are the things we can, these are the things we can, just, propose. As we propose this thing, then few points we can actually observe from here. Okay, I hope all of you are able to view this thing clearly. Yeah, or I can reduce a little bit. Yeah. Now the point O is called the origin. Okay, The distance OM is called the abscissa. The distance PM is called the ordinate. Both abscissa and ordinate together called coordinates. So what we can say? The coordinates of the point P is the ordered pair alpha comma beta. So whatever I just said, let me put it down. And as I was telling, that these are the different attributes of a Cartesian coordinate system. What are those? The first one is the point O. Point O is called the origin. This is the point, origin. Okay. The distance OM is called the abscissa. That means how far it is from the y-axis. So this is the distance alpha. So this distance alpha is called the abscissa. And the distance PM, that is beta, that means how far it is from the x-axis, is known as the ordinate. Both abscissa and ordinate together called coordinates. So that means both alpha and beta together, and that leads to the ordered pair what we discussed a few minutes back. So the coordinates of the point P is the ordered pair alpha comma beta. I hope it is clear, dear students, that how we can find the coordinates. Okay. Now, a few points we'd like to mention here, very basic points, that along with OX, you can find, and there is OX dash also. So I should also mention about this thing, that what about that OX dash and what is about the OY dash. And let me bring it here. The point is that let us now produce XO backward, okay, to form OX dash, and YO backwards to form OY dash. Now let's remember the following thing. The line parallel to OX are positive, and the lines parallel to OX dash are negative. The line parallel to OY, are parallel to OY are positive, and the lines parallel to OY dash are negative. What is meant by that is that when you go in the left hand side of the origin O with respect to the x-axis OX, then it is negative, and similarly if you come down with respect to the OY, and then it is negative. Okay, so this is the fundamental about the Cartesian coordinate system. Now what we are going to discuss, dear students, is the next coordinate system, that is called the polar coordinate system. Okay. So here also, like Cartesian coordinate system, here also in the polar coordinate system there are different attributes, dear students. So what are those attributes? And first we will discuss that, and after that we will discuss what is the relationship between the Cartesian coordinate system and polar coordinate system. So let's first discuss. In the polar coordinate system, dear students, is that how we describe is that there is I just give a touch base that is called r comma theta. So what it is, let us understand exactly. So now, as you see in the adjoining diagram, let OX be a given line and P be any point in a certain plane. You can consider the plane of this digital board. Let theta be the angle made by the line rotates in moving from OX to the position OP. O is a fixed point. Okay, this point O is a fixed point, and this OX is also a fixed line. The point O is called the pole, and the line OX is called the initial line. Correct, dear students? The way I just give an analogy with the Cartesian coordinate system, there are two fixed straight lines One is called the x-axis, and the other one is called the y-axis. Similarly, in case of the polar coordinate system, there is a fixed point, that is O, is called the pole, and the fixed straight line OX is called the initial line. Okay. Now, with respect to this fixed point, that is pole, and the fixed line, that is initial line, we can represent any point in the plane of this digital board by means of two parameters. Okay. The first parameter is called the R, and the second parameter is called the theta. So what is R? R is the length of the line OP. R be the length of the line OP. And what is theta? Theta be the angle made by that line OP rotates in moving from OX to the position of OP. So you have two straight lines OX and OP. So the angle between from OX towards OP, whatever the angle you made, that is called the theta. So with these 2 points, with these two, ordered pair, that is r comma theta, you can represent a point uniquely. Here also you may think, sir, is it important to have these two, attributes, that r and theta? Yes, it is important. With only r, you cannot represent a point. Okay, let's understand. Let me explain you by means of a different color diagram. Suppose this is the initial line and this is the fixed point. That is the initial line OX and fixed point O. Now we are representing a point something like this. Here is a point P, and which is at a distance R. We are saying no, only R is the sufficient. Then it is not possible. How it is not possible? We can just construct a circle with O as the center and R as radius. Then you will get the circle something like this. Correct now? Now any point on this circle having the same R, the radius, then you are not able to represent the point uniquely. Correct now, dear students? So we need another attribute, and that parameter also you can define in this context, and that is called theta. Now with only theta we cannot also represent a point uniquely. Suppose we call this is theta, then any point on this line is actually, suppose this is another point, this is another point, this is another point, all are actually making an angle theta with the initial line OX. But then also you are not able to represent the point uniquely, only with theta. Now when you take that ordered pair R and theta together, then you are able to represent that point P uniquely. What does it mean? It means is that it is impossible to find any other point in the plane of this whiteboard having R and theta as a distance from the origin in a pole, and O is a point pole, and makes an angle theta with the initial line. Okay, where OP is that line and OX, and from OX to OP, that angle is theta, measured counterclockwise, anti-clockwise. Impossible to find. So as it represents uniquely, hence it is acceptable that okay, this is a polar coordinate system also can represent a point. Now dear students, here are a few points I would like to mention. That R, that is what is called, there is a formal name for that R, that is called the radius vector. And the theta, what is the angle XOP, that is called the vectorial angle. So what we see, dear students, the point P is represented by means of the ordered pair R comma theta, and is known as the polar coordinates of the point P. And what is OP? As we just said, OP is known as the radius vector, and that angle is that XOP, that angle is known as the vectorial angle. Okay, so with this we are done with the polar coordinate system. Now, the fundamentals of polar coordinate system we'll discuss later about in details about it when the different situation comes. But this is the fundamental about the polar coordinate system. Now, as I said when I started discussing that there are relationship between both Cartesian coordinate system and polar coordinate system. Both used to represent the coordinates of a point. In Cartesian coordinate system, as I said, dear students, it is in terms of x and y, as you see here, where I wrote in the first page. Yeah, in Cartesian coordinate system, as you see, it is in the terms of x and y, and in polar coordinate system, it is in terms of r and theta. Now, what we are going to do, dear students, we are going to find a relationship between this xy, that is the Cartesian coordinate system, and r theta, that is the polar coordinate system. Let's find it out how we can find this, establish this relationship. So our next point of discussion is that relationship between the Cartesian and polar coordinate systems. And here I'm going to first show with the header and then find the relationship. So let us consider a point P in a plane, okay? And let P be a point in a plane, and the point P having the following two ways of representation. The first one is the Cartesian coordinate representation, okay, in which the point P is represented by the coordinates x, y, okay? That P is represented by the coordinates x, y. And the next one is the polar coordinate representation, in which the point P is represented by the coordinates r, the coordinates r, theta. Now let's find what is the relationship between x, y, and r theta. So for that, now let us draw a diagram. Okay, so diagram is important to find the relationship between them, and let's see how we can make it. Now, as you see, the same point P is represented as x, y, and r, theta. And from our fundamental understanding about the Cartesian coordinate system, we can say that OM is equal to x and MP is equal to y, correct or not? Where M is the foot of the perpendicular from the point P to the x-axis. So that one thing though we are pretty sure that OM is equal to x and PM is equal to y. Okay. Now, so we get OM. Let me write it down. OM is x and PM is equal to y. Now let us consider that right angle triangle PMO. If you consider the right angle triangle PMO, why it is right angle triangle? As I said, that PM is perpendicular to the x-axis. So here PM is perpendicular to the x-axis, OX. So then what we can find? We can find in the triangle PMO is that sine theta is equal to y by r. Correct or not? In the triangle, in the right angle triangle, in fact, I can say. In the right angle triangle PMO, we get, and the same point P is having coordinate r comma theta under polar coordinate system, we know what is r. R is equal to that OP, and what is theta? Theta is the angle between OX and OP measured anti-clockwise. That is from OX to OP. OX towards moving to OX, from OX moving towards OP anti-clockwise. So what is sine theta? Sine theta is equal to, in the triangle, what we can find is that it is PM by OP. So it is PM by OP. So this implies sine theta is equal to, PM is y by r. That implies y is equal to r sine theta. So if you know r and theta, you can find the value of y. In a similar manner, you can find the value of cos theta. What is cos theta, dear students? Cos theta is equal to OM by OP. So this implies cos theta is equal to OM. OM is nothing but x by r. That implies x is equal to r cos theta. So what we get? X is equal to r cos theta and y is equal to r sin theta. So now let's give this as equation 1, and this gives equation 2. Correct, dear students? So if we know r and theta, we can find the value of x and y by means of this relationship, x equal to r cos theta and y equal to r sin theta. So that is the relationship between the polar coordinate system and Cartesian coordinate system. That means if the polar coordinates of a point is given to you, you can find what is the corresponding Cartesian coordinate. Polar coordinate is given to you means what? R and theta is given to you. So now, as you know the value of r and theta, can't you find the value of r cos theta? Yes, you can. So that is nothing but x. And can't you find the value of r sin theta? Yes, you can. And that is the value of y. And xy is nothing the value of the Cartesian coordinate system. So done. Now what will be the case if it is otherwise? Suppose x and y is given to you, and you need to find the value of r and theta. Then also you can establish the same relationship, dear students, that y is equal to r sin theta and x is equal to r cos theta. After that, what we will do? After that, we'll make squares of both the sides of equation 1 and 2 and then add. Then what we are going to get? We are going to get x square plus y square is equal to r square. So from here, what we get, dear students? From here we get r is equal to square root of x square plus y square. And here we are assuming that r is not less than 0. But in some conditions, r could be less than 0 if it is diagonally opposite. Okay. If it is diagonally opposite of the point P, then r is less than 0. But we are not discussing in this context, because here we are considering the point P is in the first quadrant. Okay. So r is equal to square root of x square plus y square. And how we can find the value of theta? So as we know, sine theta is equal to y by r, and cos theta is equal to x by r. We can divide both sides of the equation 2 by equation 1. So then what we are going to get? R into sine theta by r into cos theta. So what we are going to get is that y by x is equal to r into sine theta divided by r into cos theta. This implies tan theta is equal to y by x, since r cannot be equal to 0, because if r is equal to 0, there is no meaning, right? If r is equal to 0, there is no meaning. Hence, I mentioned that r cannot be equal to 0 in the second point. So now we get tan theta is equal to y by x, and from here we can find the value of theta. And what is the value of theta? The value of theta is tan inverse of y by x. So dear students, these are very important observations. Let me that y is equal to r sine theta, x is equal to r cos theta, r is equal to square root of x square plus y square, and theta is equal to tan inverse of y by x. These are very important observations. These are very important observations. So what is the summary? Summary, as long as that relationship between the Cartesian and polar coordinate is concerned, okay, if what we can say is that if x comma y is given, okay, then what we can write? We can write is that r is equal to x cos theta, and not x equal to r cos theta and this thing. So from here what we can write is that if x and y are given, then r is equal to square root of x square plus y square, and theta is equal to tan inverse of y by x. And the second point is that if r comma theta is given, then what we can say? We can say x is equal to r cos theta and y is equal to r sin theta. Okay, so if r comma theta is given, then we can find x and y also, and if xy is given, then we can find the value of r and theta. That is all about the relationship between the the Cartesian coordinate system and polar coordinate system. Now, dear students, we are going to discuss. We will be confined our discussion henceforth with Cartesian coordinate system. And whenever it is required a polar coordinate system, we can convert it because we know the relationship. But as Cartesian, in general, Cartesian coordinate system is more popular. Okay, so as it is more popular, so all our discussion henceforth will be confined with the Cartesian coordinate system, and as and when required, we will be discussing the polar coordinate system. Okay, the few important points about before we start discussing about the straight lines, that is the point of our discussion. Before that we need to know a few important things about about this Cartesian coordinate system. And the first one is that the distance between 2 points. Most of you are aware of it because these were all been discussed in the previous years of your class 10 standard or 9 standard. But for the sake of completeness, it is important to discuss this thing. So, and hence I'm discussing. So, I hope there should not be any question here, but you can, if you have, you never hesitate to ask me. So first is the distance between 2 points. So let P, whose coordinates is x1 comma y1, and Q, coordinates x2 comma y2, be 2 points. Then, as we know the coordinates of the point P and Q, we can find the distance between the point P and Q, and it is actually the straight line distance. PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Just a minute. There are two doubles has been given. Just a minute. There is a small printing mistake was there. Now I corrected it. Okay, dear students, so that is the distance between 2 points. And distance between 2 points means what? It is a straight line distance, and that is always unique. That means what? If you have a point P here having coordinates x1 comma y1 and another point Q here having coordinates x2 comma y2, then the distance between P and Q is actually the straight line distance, and that is fixed. That is a straight line distance PQ that is fixed, and the distance is obtained by square root of x2 minus x1 whole square plus y2 minus y1 whole square. And you know, dear students, when I'm drawing this from P to Q, it is a straight line. Assume this is a straight line, though in my drawing it doesn't look like, but it is a straight line. You assume this thing. Okay, so that is the distance formula. Now there is another important point that is called the section formula. Okay, the first one is called the internal section formula, and the second one is called the external section formula. So what is this internal and external section formula? Let's discuss this thing. Okay, so our next point of discussion is that section formula. Okay, let me discuss in a new page. So let me first explain you what is meant by this section formula. Okay. So suppose you have a line segment. Okay. Let me draw it properly. This is a line segment. So one end of the line segment having is the point A having coordinates x1 comma y1, and the other point is point B having coordinates x2 comma y2. Now you get a point in between the line segment AB. You get a point in between a line segment AB, and that point is suppose P here. Okay. Now there will be another case. So suppose we have the I'm just representing the same line segment AB here. Here is the point A having coordinates x1 comma y1, and another point B having coordinates x2 comma y2. But here also you get a point P, but that point P is that not in between that line segment AB, but if you extend that line segment AB in that one, so you get a, suppose you extend like this, and you get somewhere this point. Let me draw it properly. So you get this point. Suppose this is the point P here. Now, or we can name it as Q. Let's name it as Q. So now, this point P is known as, it is actually internally dividing the line segment AB. Whereas the point Q is known as the externally dividing the line segment AB. So, in the left hand side, what you see, dear students, that is called internal section. And whatever you see in the right hand side is known as the external section. Now, what is our target? Our target is to find the coordinates of the point P and Q. But how you can find that coordinates of the point P and Q? What about the information I discussed? That is not sufficient to find the coordinates of the point P and Q. Why, you know? Because as I said, P is a point in between the line segment AB. That means P could be anywhere, na? P could be here, or P could be, I can say that P could be here, or P could be here, or P could be here. Then how it is possible? It is not possible with this only information of the coordinates of the point A and B. What extra information we know, dear students, is that in which ratio that point P is actually dividing the line segment AB. Okay, that means we need to know what is AP is to PB. So if we know that AP is to PB is equal to M is to N, and dear students, here I can say there is a misconception. The moment I say AP is to PB is equal to M is to N, that doesn't necessarily means always that AP is equal to M and PB is equal to N. What we can say that AP is equal to Km and PB is equal to Kn, so that their ratio is M is to N. Never assume that AP is M and PB is N. No, that may be one case when K is equal to 1. But their ratio is in the form of M is to N. Then this point is unique, correct? Huh? It is impossible to find any other points in between the line segment AB which divides the line segment AB internally in the ratio M is to N. It should be the only point P. So now as we uniquely identified the point P, now we can find the coordinate of the point P. What is the coordinate of the point P, you know, dear students? In this one. So what we find is that AP is M, AP is to PB is equal to M is to N. There's a technique to remember. So let me tell you. From M, you actually make an association with the point B, coordinates of the point B, and from N, you make an association with the coordinates of the point A. Then what we can find the coordinates of the point P, dear students, is actually M into x2, M into x coordinate of the point B, that is x2, plus N into x coordinate of the point A, that is x1, mx2 plus nx1 divided by m plus n, comma. See, in the similar manner, the symmetry rule, okay, same pattern, m into y coordinate of the point B, that is my2, plus n into y coordinate of the point A, that is y1, n y1 divided by m plus n. So we get the coordinates of the point P. Correct, dear students? Now, in the similar manner, we can find the coordinates of the point Q, which divides the line segment, you know, AP externally in the ratio M is to N. What does it mean? It means that AQ is to AQ is to BQ is equal to M is to N. Now, in that case, how we can find the coordinate of the point Q? The coordinate of the point Q we can find is that in the same manner we can find it out is that, you know, M into x2, just only one difference here. Is that M into x2 minus n into x1 divided by m minus n, and m into y2 minus n into y1 divided by m minus n. This is 2, by the way. Okay. So this is, you know, left hand side what you see, dear students, that is known as the internal section formula, and the right hand side what you see, it is called the external section formula. Section, division, the way you can name it. Okay. So it is internal, what I can say, dear students. So let me write it down here. So this is known as internal and this is known as external. So any understanding difficulty or anything, please do let me know. Okay. Now you may have a question that, sir, how to derive this thing? Okay, so all these derivation are you can do by your own also, using the fundamental concept of, you know, geometry and the coordinate system, the distances. With this you can find it out, the relationship between them. And another one is that what I can say is you know, that you can do it by your own. But As long as our entrance is concerned, those derivations are not very important. But what is important is that you remember the formula. So now, dear students, let me formalize, the discussion what I mentioned. So and you will get the point. So first, I talk about the internal division formula. So as you see here, let R alpha comma beta be the point, okay, divides the line segment P x1 comma y1 and Q x2 comma y2 internally in the ratio m is to n, where m n greater than 0. Then the coordinates of the point R alpha comma beta is obtained as alpha is equal to mx2 plus nx1 divided by m plus n, and beta is equal to my2 plus ny1 by m plus n. In the similar manner, I can describe you the the formal definition of the external division and related to its the formula, and here it is. So here what we are saying, dear students, that let R alpha comma beta, that means coordinates of the point are alpha comma beta. Let R alpha comma beta be the point divides the line segment, P divides the line joining the points P x1 comma y1 and Q x2 comma y2 externally in the ratio m is to n, where m n greater than 0 and m is not equal to n, then it is of no meaning. Okay. Then the coordinates of the point R alpha comma beta is mx2 minus nx1 by m minus n, and beta is equal to my2 minus ny1 by m minus n. Okay. So this is about the internal and external division formula. Now, dear students, I would like to conclude the class here. In the next class, what I will be discussing about the coordinates of different centers of a triangle, like centroid of a triangle, incenter of a triangle, excenter of a triangle, orthocenter of a triangle, circumcenter of a triangle. All these points we discussed in brief during the discussion of properties of triangles, for which the video lecture is available in YouTube and also in the online platform at KonarClasses.com. But what I want to discuss, all these, coordinates of these different centers from a, coordinate geometry point of view. Okay, so these are the points we'll be discussing in the next class, and we will proceed further. So I would like to conclude the class here. If you have any specific question, you can let me know. Otherwise, in the next class. Thank you very much.